Welcome to Mrs. Mahoney's podcast, number 4 for Unit 2. This is covering page 7 for the notes, and this is going to be our last podcast for this unit. Today, we're not going to be doing a new equation. We're just going to be combining two of the equations we've already looked at. So, we're looking at our heating. Today we're going to be using the heating curve of water, and we're going to be drawing them every time we do a problem. Even when I'm making a problem, I draw it so I can see what I need to be doing. So to start with, let's look again what this heating curve even means. In the beginning, you have just a solid and it's heating up to this point. That's where it's going to start to melt. To calculate that point, this is down here where I'm saying A, all I'm doing is increasing the temperature of the solid. So whenever you have a temperature change, you use your MC delta T. Notice the S's down here, those are for solids. Next, we need to melt the solid. For the melt, we're going to use heat of fusion. Where it says N, because I used to do this with moles, just change it to grams. And it's just the grams times what the heat of fusion. That's where we have a phase change. Next, we have one phase only, just heating it. MC delta T, those are L's for liquid. Then what do? Boil. And again, instead of N for moles, you're going to just change that to a G, and it's going to be grams times heat of vaporization. Then we have just gas, and it's going to be the mass times the specific heat of gas times temperature change for the gas. So look in your chart. You have to just be careful. Here's my heat of fusion, vaporization. The specific heats change depending if it's a solid, liquid, or a gas. Now I have water, aluminum, and this is ethyl alcohol because we're going to be doing some problems with those a little bit later. So let's just kind of look at how we can solve these. Now typically, again, I can do it two ways. I can break them apart or I can put it all together, and I'm going to show them both ways. So the first one, I'm just going to do it in parts, just like this says over here. A, B, C, D, and E, if needed. I don't always have to do all 5 stages. So what I do is I draw myself a little picture to see how many stages I have to do. So when I'm reading this, I'm starting at -40 and I want to go to 130, and if I have ice and steam, I'm looking at water. Well, I know water melts at 0, boils at 100. Now obviously it's not going to be to scale. I'm just doing this so I know where I'm starting. So I start down here at -40 and I'm finishing up here at 130. So that means I have just a solid, then I'm going to have to melt it, and then I'm going to have to heat my water, then I'm going to boil, and then I'll heat it up. I have 1, 2, 3, 4, 5 calculations to do. So I'm just going to start. First thing I have to do, I'll start with that calculation A. To increase the temperature of a solid, this is where I use Q is going to be MC delta T. So what is my mass? Mass is always going to be the same. So it's going to be 180, and this should be Q equals, it's 180.2 grams times specific heat, but it's of a solid. So look back up on your graph, and the specific heat of a solid is 2.10. And how much did this temperature change? Well, right here, temperature change, final minus initial. So how much did it change? It changed 40 degrees. And it's 40.0. So you can plug that in, and I'm just going to go ahead and round it to 3 significant figures. And if I do that math, I know that I get 15,100 joules just to heat up the solid. That's gotten me to here. Next phase, we have to go from here to here. I need to melt it. So Q is grams times the heat of fusion, which is 334 joules per gram. So I have 60,200 joules is going to take to melt the solid. So I've gotten it here to now I have just liquid. Then what do I need to do? Heat it. How much am I going to heat it? 100 minus 0, I'm going to heat it for 100 degrees. So my equation C said, okay, heat it. Mass, still 182. Specific heat, this time's a liquid, so I use 4.184, and I heated it for 100 degrees. So I punched that all into the calculator, 180.2 times 4.184 times 100, and I get 75,400 joules to heat the liquid to its boiling point. What do we do next? We have to boil the liquid. Mass, grams, times heat, but this time it's heat of vaporization because you're boiling it, going from a liquid to a gas. So that number is 2,264. So this is obviously going to be a lot more energy because there's a lot more per gram. 408,000, rounded again to 3 significant figures. The last step, heat just the steam. So mass, specific heat, this time is for a steam, for a gas, and I'm only heating it 30 degrees, because if I come up here, I'm going from 130 minus 100, so I get 30 degrees. It's changing in this point right here. So then that took 10,800 joules for that point. So now I have all of these components, but I want to know totally to go from the beginning to the end. Take these and add them all together. 15,100 plus 60,200 plus 75,400 plus 408,000 plus 10,800. So you add all of that together and you get 5,609,500 joules. But then the final thing, I said kilojoules. So I'm just going to do a quick conversion because I know in 1 kilojoule there's 1,000 joules. So my answer to 3 significant figures in 570, I put that decimal to make that zero count, kilojoules. Okay, not hard math, just lots of little places to make mistakes. So you just really have to be careful on these, that you make sure you put the right point in. Okay, I'm just going to do a couple more problems and to show, do I have to do all 5 steps? Answer's no. This is pretty much as hard as it gets. This is all 5 steps. There won't be any more steps than that, but there can be less steps. And again, this is why I draw a picture, because look at this one. How much heat's required to convert? First thing I see, 100 kilograms. I'm going to have to change those to grams. And then look at my temperature, and it's still water, so I know my graph is still going to be numbers with water. So I'm going to have my melt at 0, boil at 100. So where am I going? I'm starting at minus 10. So I'm going to have to warm up to 0. And then at 0, what do? I start melting. And then it says right here, I'm starting, but I'm stopping once I get to the water. So I'm going to stop right there. So I only have 2 steps that I have to do. I'm just going to have to say, okay, first I want to heat it up. Excuse me, let's make a change there and use the right formula if I'm heating it up. First I want to heat it up, which means, see, even I make mistakes, but you catch them. And you know me, I make a lot of mistakes. MC delta T, that's when I'm heating it, plus melting it, heat of fusion. And I'm going to just do it in one step this time instead of doing it in all the different steps. So just the total heat and mass. Well, we better change that first. So kilograms. So I know 1 kilogram is 1,000 grams. And I'm just going to go ahead and write this in scientific notation. So I have 1.00 times 10 to the 5th grams. So that's my mass, and it's always going to be my mass times 10 to the 5th. Specific heat. It's a solid, so I use the specific heat for a solid. And how much did my temperature change? 0 minus a negative 10, so that's 10 degrees. Plus, same mass, 1 times 10 to the 5th. And I'm melting, so the melting heat of fusion is 334. That's it, 2 steps this time. So now I can just do it all at once in the calculator. 1 times 10 to the 5th times 2.1 times 10 plus 1 times 10 to the 5th times 334, and you should get 355 times 10 to the 7th joules. Now you should be having your calculator out, working these, pausing it as you need to make sure you're getting that, and double check, because I make mistakes, as Ashley found out on another one, so double check that I've pulled out the right numbers. And that's part of it, is you can come in the morning and say, Mrs. Mahoney, you made a mistake, and I want you to catch a mistake if you find a mistake. Okay, last one we're going to look at together is number 7. And there's something a little bit different about this, because instead of water, look at what I have, ethyl alcohol. So that means when I draw my graph, only difference, when I draw my graph, I need to make sure I know where my numbers are. So ethyl alcohol melts at a negative 120 and it boils at 80. So then I just say, okay, where am I going from? Well, I'm starting here at 70, so actually below the boiling point. So now I'm cooling down. So I'm starting at 70, I'm going to cool down until I get to 120, then I'm going to freeze, and then it's saying you're going to go down until you reach this 140, negative 140. So I have 1, 2, 3 steps. The difference, I'm cooling. So if you're cooling, it's exothermic. You're going to have a negative number. Don't forget that. Every number needs to be negative. I'm going to do it all again, all at one step. So I'm going to start at the top. What am I doing? Changing my temperature. So that's going to be MC, so I'm just planning ahead. MC delta T when it's a liquid. Then what am I going to do? I'm going to freeze it, which is grams, heat of fusion, but I just know this will be negative because it's exothermic, and then MC delta T when it's a solid. So I can plug those numbers in. I have 92 grams. That's my mass. Specific heat for a liquid, and for liquid ethanol, make sure you're looking at over on your ethanol chart. That's 2.46. And how much did my temperature change? It went from, so over here, negative 120 minus 70. So it cooled down 190 degrees. And the negative again means just that it's cooled. We're going to freeze it. 92, freezing's exothermic. That's why it's a negative 186. Now we're going to just keep on cooling the solid. 92 grams. Specific heat for a solid is 1.9. Excuse me, specific heat for a solid is 2.2. Careful, make sure you grab the right numbers. And how far did it cool? 20 degrees. So you're being careful of the negative signs, you just plug that in. 92 times 2.96 times negative 190 plus 92 times negative 186 plus 92 times 2.2 times negative 20 equals. You can just do it all at once. And you get a negative 64,200 joules. This is a lot of times why we use kilojoules. If you want to change it to kilojoules, that'd be a negative 64.2 kilojoules. Either answer would be fine. It's acceptable. Okay, I want you to try number 8 by yourself. Now with number 8, when you're looking at this, be careful. You're starting at the solid, going to a gas, so make sure you pay attention to the states. And there's one other thing I want you to do a change. When I looked at this heat of vaporization for aluminum, it made absolutely no sense. I just knew that that number wasn't a real number, and that kind of bugged me. So I went and got a real number for it. So once I can find my pen, there it is again. So cross out this number and just put the real number so that the number will be more logical, and the real number is 10,900. It takes a lot of energy to get a metal into a gas. Okay, so tomorrow when you come in, we'll go over that first one, and the rest of the Tuesday and Wednesday are going to be work days on this. Draw pictures whenever you do this. Draw a picture, draw a picture. I will see you tomorrow.